Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss the topic on the eigenvalues of the matrix. Before going to discuss the eigenvalues, first of all, we need to understand what is the meaning of the characteristic matrix, what is the meaning of the characteristic polynomial, what is the meaning of the characteristic equations. And based upon that understanding of all these three definitions, then here we need to find the eigenvalues. First of all, we need to discuss what is the meaning of the characteristic equations. And before that, what is a characteristic matrix? Here, characteristic matrix is nothing but, for example, if we consider A is equal to, like these are the one of the example, there is a 3 by 3 matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Be a square matrix. With respect here, the order is a 3 by 3. Here, I. That I is also corresponding the 3 by 3, the unit matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1, an identity matrix, and also the lambda be any scalar. And with the help of this, assume that given matrix A, I, and lambda is a scalar. With the help of these three, if it is considered within the matrix, A minus lambda I is called the characteristic matrix. That means with the help of the matrix A and I and lambda, we obtain in the matrix notation, that is A minus lambda I is called the characteristic matrix. And further, based upon this one, we need to find out what is a characteristic polynomial. The characteristic polynomial is nothing but the determinant of A minus lambda I is called the characteristic polynomial. While we are going to observing here, if it is obtained in the matrix, that is a characteristic matrix. If it is the data of finding, the value is called the characteristic polynomial. That means we obtain in terms of lambda that depend upon the given order of the matrix. For example, the 3 by 3 matrix, then we obtain the lambda cube, and again the 2 by 2 matrix, we obtain the lambda square. That is the meaning of we obtain the data of A minus lambda I is called the characteristic polynomial. And further, characteristic equations. The characteristic equation is nothing but whatever we obtain the data of A minus lambda I, if it is equal to 0, that means whenever we say that equation that is compulsory is equal to 0. After either the constant LHS is equal to 0 or right side, whatever it may be, that is equating 0. But here the characteristic equation is nothing but whatever we obtain the characteristic polynomial, we equating 0, that is called as a characteristic equation. That means here these are the three different definitions we need to remember. One is the characteristic matrix, that is in terms of the matrix. The characteristic polynomial is nothing but in terms of the polynomial, and is equal to 0 is called as a characteristic equation. And based upon this one, we need to further proceeding to finding the eigenvalues. That is with the help of the characteristic equation. By solving that equation, we obtain the values. That values are called the characteristic values or eigenvalues. And we need to discuss based upon that characteristic equation, that is eigenvalues, that is one of the example for each one. For example, characteristic matrix with the help of the example. For example, let A be any square matrix of order n, and then the matrix data of A box of A minus lambda I is called the characteristic matrix of A. That means we obtain in terms of the matrix with the help of the one example. Here A is any matrix, that is the corresponding I is also unit matrix, and lambda be any scalar. For example, the example, it is A is equal to 1, 2, 3, 4. That means it is a consider, that is a 2 by 2 matrix, and box of A minus lambda I with the help of that 1 minus lambda, because of A is the matrix 1, 2, that is a 3, 4, and lambda be any scalar, and again I. That I is nothing but the corresponding unit matrix order is 1001. With the help of this, the box of A minus lambda I is equal to, it is A 1 2, that is a 3 4 minus lambda into 1001. It is nothing but 1 2, that is a 3 4 minus of, that is lambda 0 lambda. And finally, we obtain that 1 minus lambda, 2 and 3 and 4 minus lambda. This is the definition with the help of that, that is a characteristic matrix. And similarly, the characteristic equation. So that characteristic polynomial. Yeah. Here, the characteristic polynomial. The characteristic polynomial is nothing but whatever you obtain the box of, that is a matrix of A minus lambda I. If we find out that is a det, that means the det of A minus lambda I is called the characteristic polynomial. That means same based upon whatever we assume that example, then here the det of A minus lambda I is equal to, here that is a 1 minus lambda into, with the help of that given matrix, that is a 1 minus lambda minus 2 and 4 1 minus lambda. The equation should be like that, that is a 1 minus here 1 minus lambda into 1 minus lambda minus of, that is a minus 2 into, that is a 4. By solving this one, we obtain that lambda square minus 2 lambda plus 9. This is the meaning of the characteristic polynomial. That means finally we obtain in terms of, that is a like a polynomial terminology. That is the meaning of characteristic polynomial. And further, characteristic equation. The characteristic equation is nothing but whatever we obtain, that is with the help of the matrix and with the help of the lambda, with the help of that I. If it is a finding the data of m minus lambda I, we equate the 0. That means we obtain, for example, that A B is any square matrix of order n. Then data of a minus lambda I is called, is equal to 0, is called the characteristic equation of A. For example, here let us consider this is the same matrix. By equating, that is a characteristic polynomial is equal to 0. That means these are three different terminology to remember. One is the characteristic matrix and a characteristic polynomial and a characteristic equation. And whatever we obtain here, with the help of that example characteristic equation, while solving, we get the solutions. That solutions are called the eigen values. Now, we need to find out how to find the characteristic equation for 2 by 2 matrix under, that is a 3 by 3 matrix. Because of today, we are going to discuss that particularly on that eigen values of the matrix from the given matrix. Either it may be 2 by 2 matrix or any 3 by 3 is a matrix, and similarly any 4 by 4 and 5 by 4 also, based upon this is the procedure. For example, here while we are going to finding the characteristic equation, that is with the help of the determinant, we need to remember these are the two conditions, that is based upon the 2 by 2 and based upon the 3 by 3. For example, the 2 by 2 matrix is A by A11, A12, A21, A22, and similarly the 3 by 3 is also A11, A12, A13, A21, A22, A23, like A31, A32, A33. While we are going to finding the polynomial wise, that according to that first one polynomial and with the help of the equation, here any matrix is given like the 2 by 2 with the help of the data of m minus lambda I. In the equation format, you obtain the data is lambda square minus s1 lambda plus s2 is equal to 0. That is because of the matrix is the 2 by 2. Under the 2 by 2, while we are going to find in the data, the equation should be satisfied. Lambda 1 square minus s1 lambda plus s2 is equal to 0. The meaning of s1, that means the trace of the matrix. And in this given matrix, the trace of the matrix is nothing but that is sum of the diagonal elements. And it is nothing but the sum of the diagonal elements are, that is a a11 and also a12. That is the meaning of the trace of the matrix, that is the sum of the diagonal elements. That is the principal diagonal element. And similarly, the s2. And sometimes it is in branch of, this is the s2. That s2 is nothing but the data of the matrix. That means the date is, as you know that according to the 2 by 2 date is AD minus BC. That is date of A and again A11, A12 and again here A21 and A22. That is nothing but AD minus BC is A11, A22 minus A12 minus A21 into A21 is equal to value. This is the meaning of the data of the 2 by 2 under that AD minus BC. And further, the matrix is the 3 by 3, and under the 3 by 3 is also, while we are going to finding the data, the equation should be satisfied, that 3 by 3 order of the polynomial equation. And the order of the polynomial equation here, that is a lambda cube minus s1 lambda square plus s2 lambda, and again minus s3. And here also sometimes it is a s3 is equal to 0. That means, and same like that under the 2 by 2, but here that s1 is the sum of the principal diagonal elements, that is nothing but the sum of the diagonal elements, and here also it is a trace of the matrix. And trace is nothing but, according to here, it is a a11 and a22 and also a2, a33. That is the meaning of the sum of the diagonal elements. And similarly, the ds2. The ds2 is nothing but sum of the minors of an order 2 of the diagonal elements. That means here clearly showing that s2 is equal to the sum of the principal diagonal, that is a minus. For example, the principal diagonal elements are a11. That means you particularly delete that particular row and column. The rest of the values are a22, a23, and a32, and a33. And second one, the principal diagonal elements, same the particular row and column delete. The rest of the values are that a11, a13, a31, a33. And finally, that is the third one, the principal diagonal elements, that is a minus. That means same the last row particular column and you delete. The rest of the values are a11, a12, a21, a22. This is the procedure to involving, that is S1 and S2. And whereas that S3 is nothing but here clearly the data, as we know that how to find the data of the given matrix, then find the solutions. And after calculating like according to S1 and S2 and S3, we need to replace in the equation. Then we get that lambda square lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to, that is a 0. That is nothing but it is a data of the matrix. And these are the, we need to recall or remember the formulas under while we are going to finding the eigenvalues, and again that is a particularly characteristic equations. For example, under the 2 by 2, the first method, that means in the general method, that let a is equal to 0, 1 and 1, 0, find the characteristic equation of, that is a. That means here they are asking to find out only the characteristic equations. And as we know that according to any characteristic equation, with the help of that, the data of a minus lambda is equal to 0. That is the definition of the characteristic equation is the data of a minus lambda is equal to 0. But here already given that A is a matrix, that is a 0, 1, 1, 0. That is the equation with the help of like this, that A is a matrix consider. And here first find out A minus lambda I, that is A is the 0, 1, 1, 0 minus lambda is the 1, 0, 0, 1. And again based upon this one we obtain that it is clearly the problem is A minus lambda is a minus lambda 1 and again 1 minus lambda. But now we need to repair the data of this one. The data of is nothing but, as we know that 2 by 2 under matrix, that is like AD minus BC. And again here the data is nothing but AD minus BC, while we are solving lambda square minus 1 is a 0, because of according to AD minus BC is equal to minus lambda into minus lambda minus 1 is nothing but it is a lambda square minus 1 is equal to 0. That is the meaning of finding the in general procedure to find the data of A minus lambda is equal to 0. But here whatever we learn according to that, the short method, it is under the 2 by 2, that is a lambda square minus s1 lambda plus s2 is equal to 0. And while we are going comparison that here lambda square, that means lambda square minus s1 lambda plus s2 is equal to 0. Here as we know that it is a lambda square, that means that simply as it is replace the lambda square. And s1, that s1 is, as we know that given the formula, that is a trace of the matrix, that means the diagonal sum of the values. And here the sum of the diagonal elements, the sum of the diagonal elements are here, it is a 0 plus 0, because of the sum of the diagonal elements are, that is 0 and also 0, that is 0 plus 0, it is equal to 0 value. That is nothing but S1 is the value is 0. And further, we need to find out what is S2. That S2 is nothing but the determinant of the matrix, because of, as we know that S2 is nothing but the data of the matrix. The data is nothing but here it is a 0 into 0 and again 1 minus 1. That means the data of 0, 1, 1, 0. That is AD minus BC, as we know that is Z0 minus 1 is equal to minus 1. That is the value of the data of the value. After getting this S1 and S2, we need to replace in the first equation because of they are asking to find out the characteristic equation. Therefore, the characteristic equation of the given matrix is equal to the lambda square minus 0 into lambda minus 1 is equal to 0. Therefore, the middle of the term it will be 0. Therefore, lambda square minus 1 is equal to 0. This is the required the equation what they are asking the problem. Find the characteristic equation. It is a short method by using the according to lambda square minus s1 lambda plus s2 is equal to 0. And these are the clearly we understood under the 2 by 2 matrices that the first method and also the second method. First method is nothing but it is a general method, and again the second method is by using the short method, that is a formula. And similarly, for example, the 3 by 3 matrix. And here find the characteristic equation they are asking of the matrix. It is order is a 3 by 3 matrix. And here also, according to the characteristic equation of the matrix is equal to the theta of A minus lambda is equal to 0. That is the definition of the characteristic equation. And here already given the matrix A, and as we know that lambda is a scalar and I is a particularly that suitable matrix, we need to assume that that is a unit matrix of order 3. Therefore, based upon that A minus lambda I, we need to find the dead value. And further here A minus lambda I, that A is nothing but the given matrix minus lambda is a scalar and I is a unit matrix. And with the help of this, the matrix notation, it is a 2 minus lambda, and again here also it is according to 1 by 1, that is 2 minus lambda, and again here 2 minus lambda, the equation should be 2 minus lambda 1 2, and again 0 minus 0 is 0 and 2 minus lambda once again, and here also the diagonal elements are, it is clearly the values minus lambda, and it is a matrix only, it is a characteristic matrix only. But they are asking to find out what is a characteristic equation. That means the data of A minus lambda I is equal to 0, we need to find out. While we are going to applying the data of the 2 minus lambda 1 2, and this is the data we need to find out. Here, as you know that according to general method, the 3 by 3, the first one into the delete that particularly, that second one into that is AD minus BC minus of the particular value, and again the delete that particularly. By using the concept of according to finding the data of A minus lambda I, the value should be, it is lambda cube minus 4 lambda square plus 5 lambda minus 2 is equal to 0. This is in general method, that is the first method to find the characteristic equation. And similarly, now we need to further finding what is the short method to find the 3 by 3, that is a characteristic equation. For example, as we know that in the previous slides, here clearly that shortly the 2 3 by 3 matrix, that is a lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This is the clearly formula, lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. And in this equation is treated as 1. And here we need to find out what are the values here. Lambda cube, we require lambda is eigen values, and we need to find out what is s1, what is s2, what is s3. That means that s1, that is the meaning of the sum of the principal diagonal elements. The sum of the principal diagonal elements are diagonal elements. Here the trace of the matrix also sometimes. Therefore, the trace of the matrix is equal to, here the values are clearly, that is 2 plus 2 plus 0 is a value. That means that is the sum of the diagonal elements are, that is 2 plus 2 plus 0 is the trace of the matrix. Here the value is s1 is equal to 4. And similarly, we need to find out what is s2. That s2 is nothing but we need to find out with the help of the sum of the principal diagonal cofactors. That is the sum of the minus of the principal diagonal elements. That both are the same. And here, how to find this one? That is a very important understanding under the 3 by 3, that is s2 only. For example, while we are watching here, clearly it is showing, it is for example, that first two minor of the principal diagonal element. That means we need to find out what is a principal diagonal element of 2 and what is the principal diagonal element of 2, and what is the principal diagonal element of 0. That is a minus we need to find out. First, what is the minor of the 2 element, and second one, what is the minor of the 2 element, what is the minor of the 0 element. That we need to find out. Here, while we are going to finding first the two principal diagonal element, that is a minor. And this particular 2 minor is we delete that particular row and column. That means the rest of the values are 2 minus 1, 1, 0. That we can replace here. S2 is equal to first terminology. And second one, the second minor of the principal diagonal. That means the second one is the middle of the term. That principal diagonal elements are, that is the minor of the principal diagonal middle of the value. Here also delete the particular row and column. We need to replace the rest of the values. That matrix can be replaced here. And similarly, the third eigen, that is the third value, that minus element. And similarly, the 0 particular eigenvalue of the minor, it is delete that particular row and column. The rest of the values are 2, 1, 0, 2. That also we need to put here, this one. That means this is the first one. The first one is the 2, 1, 2 minus 1, 1, 0 is the first minor. And again the 2, 2, 0, 0 is the second one minor. And the 2, 1, 0, 2 is the third one minor. We need to find out these are the particular minors, that is the data of the value. Then we need to addition of these three. That is the meaning of the sum of the minors of principal diagonal elements. And here the first one, clearly the value it will be, by solving we obtain S2 is equal to the first one data of the value is, that is a 1, and second one data is a 0, the third one data is a 4. Now addition of means these are the sum of the minors of the diagonal elements. Therefore S2 is equal to, clearly it is a 5 value. Here S1 is over and S2 is also over, and S3. And as we know that to find that S3 value, that S3 is equal to the data of the matrix. That means that S3 is equal to the determinant of the matrix. The data of the matrix is nothing but that is a value of 2. That means as we know that 2 into that is the data of the 2 into 1 is a 0, and again plus 1, and again minus 1 into that is 0, plus 0, and again plus 2 into, like here also 0 and again minus 0. The final solution it will be 2 only. Because of this 1 0 and this 1 0 last second one, we obtain the value is equal to 2. Therefore, the data of the matrix it is clearly showing that is a 2 only. Now, by after calculating this S1 and S2 and S3, we need to replace in the whatever we consider the equation, this is characteristic equation, we need to replace, that is equation 1. Therefore, the lambda q minus S1 lambda square plus S2 lambda is equal to 0. In this, here S1 is, as we know that 4, and S2 is equal to 5, and S3 is equal to 2. And based upon this value, we need to replace in this required characteristic equation is, that is a lambda cube minus 4 lambda square plus 5 lambda minus 2 is equal to 0. This is finally our required equation of the characteristic equation. And similarly, for example, any problem is given, we need to find the characteristic equation like the procedure. Now, our target is to find the eigenvalues of the and corresponding eigenvector. But today class, we are going to discuss about the eigenvalues. That means we need to find out what is the eigenvalues, the particular problem of this one. Here, already we discussed how to the definition of the characteristic equation, that is eigenvalues. That eigenvalues is nothing but by solving the characteristic equation. That means up to now we discussed the characteristic equation. Now eigenvalues are nothing but by solving the eigenvalues, that by solving the characteristic equation, whatever we get the, like by solving the eigen characteristic equation, we get some values depend upon the, for example, 3 by 3 matrix. By solving the characteristic equation, we obtain the 3 eigenvalues. And for example, the matrix is a 2, that is a 2 by 2. By solving the characteristic equation, we obtain the 2 eigenvalues. That eigenvalues are either repeated or different, that is a secondary matter. But here, that by solving the characteristic equation, we get the eigenvalues that depend upon the order of the matrix. And here, finding that first eigenvalues. That means here, according to by the definition of, we need to find out what is the characteristic equation. That means first we are going to discuss the first method. Under the first method, in general, here that is the characteristic equation of the matrix is delta of A minus lambda is equal to 0, and A is the scalar given matrix, and lambda being the scalar, and I is a corresponding unit matrix. And with the help of A minus lambda, I is equal to, here the matrix is like this. Now again further we need to proceed in the general method, that is that is first method. And here the data of A minus lambda is equal to, as you know that 8 minus lambda into, that is 7 minus lambda minus 3 into 3 minus lambda minus 16. That is in general procedure. We need to find that what is the data of this matrix. Okay, as we know that in general method. And by solving all this like simplification, we obtain the generally according to like this. And further, we need to solve. Up to here, it is only characteristic equation, but we need to find the eigenvalues. That means with the help of that solving the characteristic equation. And here, by solving here, that first is a lambda. That means lambda is equal to 0. And again, second one, lambda square minus lambda square plus 18 lambda minus 45 is equal to 0. Therefore, by equating these are the two values. First one lambda is equal to 0 automatically, and second one by solving the second order equation, I think maybe it is a 3 comma 15 by solving that. That means by solving the second equation, the 3 comma 15. Therefore, these are the three eigenvalues. Here one is a 0, and second one is a 3, and the third one is a 15. These are the lambda values are called according to the definition. It is called as eigenvalues. And sometimes these eigenvalues are also called as a like a characteristic values, or sometimes it is also called as a eigen roots, and sometimes it is a proper values, and sometimes it is a latent root also. Latent roots or latent values. These are the some different terminology to define that are synonyms for the characteristic values or eigenvalues or eigen roots or proper values. Like these are the some different type of the like synonyms for the eigenvalues. And this is the only first method to discuss and finding the eigenvalues. And similarly, further we need to find out same this matrix. What is the second method for the eigenvalues? That is same. For example, the second method under the eigenvalues, we need to find the eigenvalues. First of all, we need to equate according to the characteristic equation. The characteristic equation is nothing but just now we discussed in the previous example, and based upon that, we need to find out what is the characteristic equation is under the 3 by 3, the lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This is the characteristic equation. Without mention that is equal to 0, that is a characteristic polynomial, but it is required characteristic equation. Therefore, based upon equating 0, we need to find the solutions. Here, again similarly in the previous example, here s1, here lambda is a eigenvalues, like that. We need to find out what is s1. That s1 is a trace of the matrix. The trace of the matrix is nothing but the sum of the diagonal elements. That is sum of the principal diagonal. Here, the principal diagonal elements are like 8, 7, and also 3 value. That is the meaning of S1. Here, it is the 18. And similarly, S2. That S2 is nothing but sum of the minus of the principal diagonal elements. That means whatever it is the sum of the minus the principal diagonal. The principal diagonal elements are like 8, 7, 3. This particular principal diagonal elements, we need to find out that particular minus of the elements. That means 8 minor is after deleting the particular row and column. That means after deleting particular row and column, that is the 8 first element, the values are 7 minus 4 minus 4, 3. That is the meaning of particular first minor, that is a principal diagonal. And similarly, that you need to find out. And second one, the middle of the term, minor. Similarly, we need to particularly the value element should be delete the row and corresponding column. And the values are that 8 to 2 and 2, 3. Therefore, that also we need to find the dead value. And similarly, the last one, the minus. That is a 3 particular value of the minor. Similarly, we need to find that eliminate that particular row and column. Therefore, the rest of the values are 8 minus 6, 7. Therefore, based upon such type of these are the particular three values minus, we need to find the dead value. Then we need to sum. That sum is nothing but further it is a sums are required. That is a addition of these are the three values. Therefore, the value should be first one it is a 5 and second one it is a 20 and third one it is a 20. Therefore, sum is equal to the total value is a 45. That means here it is a S1 is over and S2 is also completed. And further, we need to find what is a S3 value. That S3 is nothing but we need to find out what is the data of the matrix. And while we are going to find in the that is S3, as we know that according to that is value is a 0 because of here that is 8 into that is 7 into that is a 3 minus of minus 4 into that is a minus 4 and again minus of minus 6 into minus 6 into minus 3 that is a 3 and again minus 2 into that is minus 4 and plus 2 into minus 6 into minus 4 minus 2 into that is a 7. This is by solving after the simplification by using the general determinant process we get the value is a 0. Now that means we completed here S1 and S2 and S3 and it is not at all complete because of they are asking to find out the eigenvalues. That means up to here we obtain that only S1, S2, S3 but according to the equation when we are going to replace that is a lambda cube minus S1 lambda square plus S2 lambda plus S3 is equal to 0 that minus S3 is equal to 0. Here already we got it that S1 and S2 S3. These values we can replace in the equation of the characteristic equation. Therefore, after replacement of this one, it is S1 is a 18 and S2 is a 45 and S3 is equal to 0. Therefore, the equation should be clearly lambda cube minus 18 lambda square plus 45 lambda is equal to 0. Now we need to solve. And solve solution means as we know that how to find the solution. It is either the synthetic division or something the trial and error method or any factorization method. By solving, we obtain that the eigenvalues are 0, 3, 15. That is clearly we obtain the eigenvalues. Moreover, we are observing according to the first method and second method, there is no change of the eigenvalues. We get the equation and moreover it is the eigenvalues also. And here according to the characteristic equation is by using the factorization method. If you are going to observing that is alternate other method, it is take out common lambda. The rest of the values are 1 minus 8 and 45 0 and again here at lambda is equal to 0 we obtain that according to that lambda is equal to 0 is one of the rule. Here 0 and here also minus 18 and then second it is also 0. The value is 45 and again it is also 0. Then automatically it is satisfied the 0. Here the second order quadratic equation lambda square minus here with the help of this one lambda square minus 18 lambda plus 45 is equal to 0. This is the remaining the rest of the topic that is according to the first like synthetic division. And here also that by taking that lambda is equal to any values it is a factorizations 45 rest of the term and it is a minus 15 and therefore that is the meaning of lambda minus 3 and lambda minus 15. Therefore lambda is equal to finally that lambda is equal to 0 comma 3 comma 15. This is also by using the factorization method. That means by solving any like different many methods are there. By solving any method, we obtain that this is the solutions. That the eigenvalues are it is a lambda is equal to 0 and lambda is equal to 3 and lambda is equal to here it is a 15. Therefore, these are called as a eigenvalues of the given matrix. That means any matrix is given under the 2 by 2 and also the 3 by 3. Here we obtain that same equations. The eigenvalues are also we are not getting any different eigenvalues. And further, for example, this is the matrix. Now directly we need to go to discuss based upon the second method. We should not waste the time of that. Here time is saving and also easy to calculation with the help of the second method. Even it is a possibilities with the help of the first method also. We get the same equation, same the solutions. Here find the eigenvalues and it is also under the 3 by 3 and here also lambda cube minus lambda S1 lambda square plus S2 lambda minus S3 is equal to 0. And here S1, the trace of the matrix. As you know that that is a trace of is nothing but sum of the diagonal elements. The 2 plus 2 plus 2, the value is 6. And again here S2, that is the sum of the minors of principal diagonal element. And as we know that first minor of the element is the particularly delete the row and also column. The rest of the values that is a 2002. And again the second value, the particularly minor, that is also 2112. And again similarly the third one eigenvalue corresponding to finding the minors, delete that particularly row and column. The rest of the values are 2002. We need to find out these are the particularly the principal diagonal elements, the minors. And after that, we need to sum. That means addition of these are the three values. That means these are the three values. And calculating after that, one by one, first one is, that is a 4, second one is 3, and third one is a 4 value. Now, addition of these three, that is equal to 11 value. That means here S1 and S2 is open. And further, we need to find that what is the S3. That S3 is nothing but, as you know that, the simply the data of the matrix, that according to in the general method in that 3 by 3, that is also the 2 into, that is a 2 into 2 is a 4 minus 0 into something is nothing but 0 plus 1 into here also 0 minus 2, therefore 8 here it is a minus 2 is equal to 6, that is a S2 S3 is equal to 6 is the value. And here after getting that S1 and S2 and S3, we need replacing the equation, that is a characteristic equation. As we know that this is the characteristic equation, but already completed S1, S2, S3, the values are, these are the particular values. These value we can replace in the equation, that is a characteristic equation. Here, that is a lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Now further, we need to solve that. By solving the values only, we get the values. The values are called here eigenvalues, or latent roots, or proper values, or anything like that. Therefore, here by solving that, we obtain the solutions are lambda is equal to 1, 2, 3. Either it is a factorization method or synthetic division or something, any other method. By solving that, we obtain lambda is equal to 1, 2, 3 is the only final value. These are what called, that is eigenvalues or latent values or proper values. For example, this one, find the eigenvalues of the matrix, and here also the 3 by 3. Directly we need to find the shortening method. It is a lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. And here also that S1 trace, the trace is nothing but 510. And again S2, the principal diagonal elements here 1010, and second one 51 minus 70, the third one 5011. These are the particular minus of the given particular sum of the diagonal elements of the given matrix, and here we need to additions and find the values. The sum is nothing but first one is a 0, second one is 7, the third one is a 5. Here the sum is a 12. And further S3, that S3 is nothing but the data of the matrix. Data of the matrix, as we know that according to the general process, that is A3 is equal to A. And further, we need to replace in the general matrix, that is a characteristic equation, that is whatever we treated as a characteristic equation, that is a lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. We need to replace here. These are the some eigenvalues, whatever we obtain, that value we can replace here equation. Therefore, by solving this one, that means here the number order of the matrix is 3, and order of equation is also like that 3 compulsory. Therefore, eigenvalue should be, that is also 3 conditions. By solving here, the lambda is equal to like synthetic division or trial and error method. Lambda is equal to is one of the root, and rest of the values by using any synthetic division or like factorization. If one of the value we obtain, we need to do that easily. Here, like according to it is also 8. Therefore, this equation, then rest of the values are 1 into lambda square is lambda square minus 4 into lambda is a 4 lambda, and again 4 into constant 1 is a 4 value. Now again it is clearly able to find out that is a minus b whole square, like that, that is a lambda minus 2 whole square is equal to 0. That means clearly we identify lambda is equal to 2 comma 2 comma 2 is the final, these are the 3 roots. Yeah, lambda is equal to one of the two, second one also, third one also. By equating all this, lambda is equal to 2 comma 2 comma and also 2. That means in this particular matrix the eigenvalues are repeated, but we should not consider only one eigenvalue. Because of the given matrix order is a 3 by 3, we need to get that 3 eigenvalues particular the matrix. That means whatever the order of the given matrix, we obtain the number of eigenvalues are also the order of the matrix. And similarly, any matrix is given, we found that is by using these are the first method or second method, the eigenvalues. That means we need to remember according to first any finding that any eigenvalues. First of all, we need to find out what is a characteristic matrix and characteristic polynomial and characteristic equation. By solving the characteristic equation, we get the values are called the eigenvalues. And sometimes it is also known as the proper values and the latent roots, and also the eigenroots and eigenvalues and characteristic roots and characteristic values also. And like this, any problem is given, we need to find according to this the procedure, either the first method or any other shortly method, that is under the eigenvalues. In further next class, we will discuss about on the eigenvectors. That is a continuation of the part of the eigenvalues. We need to discuss the eigenvectors. If further any doubts, please give me in the link like a reply. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.